All right, Physics Teachers Are Awesome reaction video number 99. Today it looks like motion and forces. Um, Recorded with screencast-o-matic. Oh, I love screencast-o-matic. So yeah, here we go.
Now that we know about speed and velocity, we can take this a step further now, and we can talk about acceleration. So
Fun.
what is acceleration? It is the rate.
All right, so the setup seems to be, Google Slides, or that third-party knockoff of Google Slides. I think it's called PowerPoint. Maybe it's called PowerPoint. PowerPoint? Something like that. Anyways, Google Slides. And it looks like it's all been prepped ahead of time. And so the question is whether the students are given access to this. What's the idea of how they might take any notes? Excuse me. So I'm always sort of intrigued by that. Of course, the awesome part about this is everything's going to look right. There won't be any mistakes. You can really get to the stuff that matters, and you can really do some, not really post-processing, but things like highlighting things, like look at how well this is sort of highlighted. So I really think that's exciting. We'll see if there's interaction. Also curious to see if we see the mouse. I believe screencast-o-matic is the one that always lets you see the mouse, although here in the paused section we don't see the mouse, so let's watch for that.
Of change of velocity. Okay, so it's that change in speed. Or it could be a change in direction.
Yeah, love that.
Okay, because remember, velocity is a speed within a given direction. Okay, here is our equation for today. Go ahead and add this in onto your equation chart that we've been growing. A equals V of F minus V of I divided by T. Okay, and so what do each of those letters mean? A is your acceleration. That's your rate of change of velocity. Its unit is meters per second squared, so you may want to add that in on your
see the
equation
mouse?
sheet,
That's
what
cool.
the expected unit is. Now, V of F, this is your final velocity, so this is your ending velocity.
Love that.
V of I is your initial velocity, so that is your starting velocity. You have to be careful here. Read the problems very carefully so you can make sure you know which velocity goes in which location. That's a big place where students get tripped up, is they just put them in the wrong spot, okay? And it does make a difference. Since both of these are velocities, both of them should have the same unit, and that is usually going to be meters.
Boy, that's really interesting. I'm sorry, I'm kind of stuck on the technology now. So screencast-o-matic is adding this yellow circle, but notice that it's leaving behind this, and I have a suspicion that's from the recording, that it doesn't actually look like that to her as she's doing this presentation. Boy, that's really, really interesting. I think it might have to do with how all of the screen recorders basically are only looking for things that change to really try to lower the size of their videos. What you'll notice, for example, so my videos, if I add myself, like now, the size of my videos get way bigger because I'm always just moving a tiny little bit. Whereas if I were to shut off my camera and just had this static screen on there, that turns out the file size is way smaller. So now that can be an issue. It depends on how you're providing your videos to your students, right? Like YouTube always sort of streams it all right, but if it's something where they have to sort of wait for it to download before they can watch it, that matters. And so it's really interesting to look at the artifacts that can happen here. Boy, I have to say I really, really liked how she focused very, very carefully on these two subscripts here to make it clear that that's the sort of thing that can really sort of cause some kind of like dumb calculator mistakes. And my guess is she's also going to talk about ways to sort of know, wait, boy, that can't possibly be right, and say, oh, you know what, I must have gotten this wrong.
Per second. And then T stands for time. This will usually be in seconds, okay? Even though we have this extra factor in here, there's 4 factors instead of just 3, we can still use our triangle method to help us set up our equations and know how to solve for our unknown. The VF minus VI is going to go on the top, And make sure you always think of these as being in parentheses, because you always want to subtract before you divide. Okay, so put those in parentheses on your equation sheet. Okay, A is going to go bottom left, T bottom right, and then just like the triangle has been working for us so far, it's going to continue to work for us and tell us how to do these solving for the unknowns.
So I really love those kind of what do you call them, scaffolds, the approaches that you can use to really understand how to go about using these things. You know, so many of these kinematics equations are sort of one thing equals another thing divided by a third thing. And so since that happens so often, and you really don't want your students stuck in the, mechanics of how to do this, it's so great to provide something like this. So that students say, I feel comfortable. I've seen this kind of thing before. I get how I can do this kind of thing.
Okay. All right, so something that we can remember here is that a positive acceleration, so we calculate this out and we get a positive number, that means that the object is speeding up. It's gaining speed.
Love it.
If it's a negative number.
All right, make your predictions now. Put it down in the comments. Is she going to use the word deceleration? Right now, it's not there. And I know that I have a lot of colleagues who just, they hate that word. And so they're always going to say this. So I'm going to predict that she's not going to use the word deceleration. Let's see.
When you calculate acceleration, that means the object's slowing down. And so this is great because this gives us a way to analyze our work and sort of double check and say, is my answer what I expected? So if in the problem it's talking about gaining speed or going faster, we know that our answer should be positive. So when we get our answer, if it's not positive, we know we did something wrong and we need to go back and reassess and recalculate. Same idea if in the problem it says that something is slowing down or it's losing speed, hit the brakes, something like that, we know we should be calculating a negative number. So when we calculate it out, if we get a negative number, we probably did it right. But if we get a positive number, we know, okay, I did something wrong. We need to go back and double check. Okay? So just use that sort of information, keep that in mind, so you can analyze your work.
So far I'm right.
You got an expected answer.
I don't think she said deceleration.
Okay, here's
look at
all
this.
Of your units for velocity and acceleration that we've been studying. So if you don't already have this on your...
It's really interesting to look at the separation between this velocity row and these velocity rows, right? So this seems to be in the order that they kind of learned it, right? Like, everybody knows what distance is, and everybody knows what time is. And there's this new thing. And then she's introducing this new thing, but realizing, you know what, honestly, really to get this new thing, we have to do this. Now, the question is whether they ever, in an earlier session, did like D initial, D final, or even T initial, T final stuff that was going on. My guess is not, based on how we're sort of building this up. So this is really, really cool. All right, just checking the time here. I'm probably gonna come to a stop here. Really, really cool. I think that the setup of the Google Slides is very cool. I think that the screencast-o-matic with the mouse follower, I'm telling you, I've been picking on the non-mouse follower stuff that most of the screen recorders do. I really like the screencast-o-matic circle-y thing. I loved the description of the triangle. Actually, let's just see if we can scroll ahead, see if we can see an example of the triangle. Yes, let's get to right about there. Let's see if we can see it here. Let's see, roller coaster, 10 minutes, 3 seconds later, what is it? Okay, awesome. So let's see how she uses the triangle.
What kind of factors do you have here? Which equation do I need to use? Okay, so here's our triangle to tell us how to solve this. My A is my unknown, so I'm going to cover that up. That's what I'm solving for. And the triangle tells me V of F minus V of I divided by
That's so cool.
T is how I will solve this.
That's so cool. Love it. I mean, can you tell I've never used this, but I get where it's coming from.
Much easier. And then we just plug in our numbers. Okay, so our final velocity is 32. Our starting or initial velocity is 10 meters per second. And our time is 3. So we just plug that in. Okay, now remember, be careful. If you are just plugging this into your calculator, you have to tell your calculator how to do it properly. If you just type in this, 32 minus 10 divided by 3, you're going to get the wrong answer.
Quick rant about things like some excellent graphing calculators or Desmos and things like that. Desmos, things like that. Anything like Mathematica, anything that actually sort of typesets numerators and denominators, I love it, because then, you know, when you got your cursor down in the denominator, you can just type it along and everything you put down there stays there. And similarly in the numerator. This, what she's talking about, is the old style, you know, hold in your hand calculator that you gotta do this stuff right, because, I mean, my God, the number of different answers you'll get here, even though the students have done all of this good work and all of this good work, they can still get a numeric wrong answer. And until they really develop some intuition, you know, about how the size of accelerations, they're not going to really know how to double check that. All right, cool. So I just wanted to see how the triangle got used. That was super, super cool. All right, everybody. Well, hey, I hope you have a great day. And remember, physics teachers are awesome.